All right, welcome back, everyone. Today, in this video, we're going to be looking at Chapter 3, the first 2 years, body and mind. So moving away from the birthing process into babyhood. So we've survived at this point the first 9-ish months of existence. Okay. After you watch the videos and everything from that, it really is amazing that any of us make it at all, right? The chances of a child making it from conception to birth is unbelievably difficult. And then at this point, things don't necessarily get easy yet, right? Historically speaking, there was still a very high chance of death, although things have shifted today. But today we are looking at, for the first 2 years, looking at from birth basically until toddlerhood, specifically looking at the psychology and biology today. This book is kind of broken into different groupings. So each age category, we'll be looking first at the psychology and biology, what's going on inside the individual. And the second part, which will be the next video, we are looking at the social ramifications, how the environment essentially affects our development and shaping us and who we become. Okay. So, reminder, I'm going to be giving a bunch of random facts throughout this, so make sure that you do the quiz. This is how you get credit for doing or watching this lecture. And I'll let you know, they're very obvious when I give them. And I believe that's everything I wanted to mention. So just make sure you do that. Pay attention, listen for those, and away we go. Okay. So if you're following along on D2L or on the PowerPoints, again, you can find these in D2L, same spot you found the video. You can download it, you can print it off, you can just look at it on D2L, and we'll go from there. Okay, so slide 2, and I'll let you know as we go. Slide 2, growth in infancy. Body size, the average weight of children or babies born worldwide at birth is about 7 pounds. Okay, by 24 months, they've gotten to 28 pounds, so we've quadrupled our body weight in the first 2 years of life. Pretty impressive. I'm glad we don't keep growing that fast throughout life. I'd be like blue whale by the time you're my age. Average length at birth is 20 inches, and at 24 months is 34 inches, so you grow a little bit over a foot in 2 years. And then again, these are the norms, right? You can have babies smaller, you can have babies bigger, you can have babies a lot bigger. I think I mentioned before I had a friend that they had a 12-pound baby. Big baby, right? So they offset the baby that was like 4 pounds or something like that someone else had. Anyway, so yeah, but these are going to be the norms of what we expect to see. Okay, next slide, slide 3, averages of individuals. So the dotted lines are going to be the boys in this picture, and you can also find this picture in our book on page 84, down at the bottom there. And this is going to be the average weights that you will see. So the yellow color is the 50th percentile, meaning out of 100 kids on average, they are heavier than 50 kids, give or take, and lighter than 50 kids, give or take. They're right in the center. Okay. 90th percentile means out of 100 kids, 90 kids are lighter and 10 kids are heavier. And in the 10th percentile, which is the green, you got basically the same kind of deal, right? The tendency is, but the difference is you have 10 kids lighter and 90 kids heavier, so you're smaller. You'll notice that boys on average become heavier overall. So I just wanted to kind of point that out. Again, these are useful statistics to some extent. Most 1-month-old girls who weigh 10 pounds should be at least 25 pounds by age 2, as it says in our little book here. So yeah, but you know, it's not a guarantee that the males are always going to outweigh the girls. Just like here, we got some males in the 10th percentile that are significantly lighter than the girls in the 50th and 90th percentile. So again, it's just on average, males are heavier. Eating and sleeping, the rate of increasing weight in the first weeks of life makes it obvious why new babies need to be fed day and night, right? Babies do nothing basically but eat, sleep, and poop for the first couple months of life, and that's a good thing, right? I think that maybe the parents don't think so when they're having to get woke up in the middle of the night all the time. but that's what allows the baby to grow the way they do. We'll look at sleep more in depth here in a minute too, because sleep is a big part of the growing process, as well as the brain continuing to wire itself as we develop. Okay. 4, sleep. Sleep specifics vary because of biology and social environment. So again, these are the averages. Newborns sleep about 15 to 17 hours a day in 1 to 3 hour segments. So they'll sleep 1 or 3 hours, wake up, but usually are hungry or they need a diaper change. They get their needs met, they go to sleep. They wake up, they have needs, they haven't met, they go to sleep. And this is kind of just the process for most babies. Now you're gonna have some babies that might sleep like 20 hours. You're gonna have some babies that sleep like 10 or 12. That's a tough one, like especially if they're like colicky or something like that, that can be an issue. But on the averages for most people are going to be 15 to 17 for the first couple months of life. Newborn sleep is primarily active sleep. So even though they are sleeping, their brain is moving. Newborns have a high proportion of REM sleep, rapid eye movement sleep. So there's 4 stages of sleep, basically. The first stage is basically that first moment when you first go to sleep, and it just lasts a short time. From that stage, you go into a little deeper sleep, then a really deep stage of sleep. And that's where we really get rested as adults, right? And then we come up into REM sleep, which REM sleep, brain activity-wise, almost looks awake. And the reason they call it REM, it's rapid eye movement. If you look at a person who's going through REM sleep, you'll notice their eyes are moving like crazy under the eyelids. This is basically, at this point, the brain also just fires up like crazy. When we're in REM sleep as adults, our body actually sends out chemicals that essentially paralyzes our body. We get sleep paralysis. That makes it to where we don't just get up and start running around, usually. Okay, sleepwalking and the like, sometimes there's a glitch in that hormone that paralyzes us, and it allows us to get up and move around as our brains are wanting us to do, which can be dangerous. So generally, most people, it's gonna cut that off. That's the stage that most babies remain in, and this is the stage where basically the brain is wiring itself. It's sending out connections and figuring out how to make itself more efficient in this early period. So again, they're going to kind of doze off. They're able to awaken if you kind of arouse them, right? They're not just like boom out of it usually, but they also go to sleep really fast, and so it's fairly simple there. So they'll wake up a lot of times. They'll cry a little bit because they're uncomfortable or they get startled. They get comforted relatively easy usually, and then they go back to sleep. So yeah, let's see. I have some notes here. So 1 new baby in 20 sleeps 9 hours or fewer per day, and 1 in 20 sleeps 19 hours or more per day. So it's a large window again that we have there. There are some red flags. Like if they're sleeping less than 11 or 12 hours a day in a 24-hour period, it might be a red flag to get something checked to make sure, especially if they're exceptionally fussy, if they're like struggling with colic and things like that. And if they're sleeping more than 20 hours in a 24-hour period, like you might be struggling to wake them up to get them to eat or things like that. That's another possibility where you might want to check with the doctor. But those are just kind of the red flag zones, if you will. So, next slide. Slide 5. Opposing perspectives. Where should babies sleep physically? Where should their little bodies be while they're sleeping? U.S. middle-class infants sleep separated from parents, usually, right? Sleeping patterns are changing. There's some different rhythms here. Decisions to co-sleep. So co-sleeping is going to be where the baby is sleeping in the same room as the parents. Bed sharing is where the baby's actually sleeping in the same bed as the parents. And it's very much linked to culture. The choices to do so you'll find that there are certain cultures that will oftentimes do that, and there's other cultures that will have like the nursery where the baby has their own space separate from the adults. Culture, age of the infant, mother's education level, depressive state, and father's involvement all have different factors on the choices to either co-sleep and or bed share or to have a separate space completely. Cultures such as Asia, Africa, and Latin American cultures oftentimes will co-sleep or bed share. You'll notice that a lot of times the cultures that are more focused on group dynamics where the individual, your privacy and things like that don't matter as much, there's a tendency toward the co-sleeping. Places like Northern Europe, where your individual, in America and Canada and places like this, where individuality is pushed more, there's a stronger tendency towards having a nursery where the baby sleeps in their own space so that the parents can have their own space. So Asian and African mothers worry more about separation. European and North American mothers worry more about the lack of privacy. Okay. First random fact. What's my favorite color? Okay, that's going to be the question on the quiz. What's my favorite color? My favorite color is orange. I like orange better than anything. I never like wear it or hardly ever or anything like that. I like the color orange. It's my favorite. Always has been since I was a kid. So there you go. Random fact. Okay. Sorry, I'm kind of stretching for some of these random facts, but there you go. Slide 6. Brain development, part 1. Prenatal and postnatal brain growth measured by head circumference is crucial for later cognition. We have big heads, right? Humans have big heads. This is part of being a human. It's part of the reason why we're born at the point where we are and not later, is because essentially our head grows to us at the extent where we would basically almost always die. But the head rapidly grows in this first period of life. Okay. Our brain is what sets us apart from pretty much every other living thing on the planet. Head sparing is a biological mechanism that protects the brain when malnutrition disrupts body growth. So if you've ever seen those really sad commercials, like where they're showing the poorest parts of the world in like India and parts of Africa and parts of South America, as well as Southern Asia, in areas like that, you'll see these poor babies that they're like little skeletons basically, right? Their bodies are just so thin, but their head is still relatively large. It's even larger compared to the rest of their body compared to an average child. That is actually head sparing in practice. The brain is the last part of the body to struggle or to suffer from malnutrition, which kind of makes sense, right? The brain is running the show, and so therefore the brain is protecting itself as much as possible. If you're suffering like those children are, the brain is still suffering too, but not as badly as all the other organs. Essentially, the first part of your body that will go if you're struggling with food and things like that, your muscle and skeletal structure will decrease first. First your fat reserves, then muscle and skeletal, then organs, and then finally the brain. Okay. So yeah, that you can have like if you see someone who's been stunted in their growth, meaning they for example, the pygmies in the Congo jungle in Africa, they were historically very short, like very short, under 5 foot was the average height. A lot of them, when they came out of the jungle and began eating better diets and things, their average height, like within one generation, grew dramatically. They're still not like tall people, but the average male all of a sudden goes from just under 5 foot to like 5'6" to 5'8" within one generation. So that shows the diet had a key factor there. Okay, that's a real example. 7. Brain development, part 2. Exuberance and pruning. I mentioned this a little bit in the last one. So specifics of brain structure and growth depend on genes and maturation, but even more on experience. The brain initially is going to have a lot of exuberance. There's going to be lots of neurons forming, and they're going to just be like everywhere. Okay, looks like a giant overgrown hedge as far as what the brain is doing inside. The dendrites are growing out and connecting to each other, and this is that transient exuberance. This is that tendency for expansion within the brain. Okay, this expansion is increased, which we want to see, with additional experiences. And there's a sweet spot. Okay, too little experience, and the child basically won't reach its full potential because it's just not getting enough stimulation. Too much stimulation, though, and the child can experience, it'll increase the stress levels that the child then experiences, which can actually harm or hinder this expansion. It's a tough one, and each individual child is going to have a different level of what it needs and all those kinds of things. So it's a tough one. But generally speaking, the more experiences possible within that are appropriate for their age, the better for the brain development. Okay. Unused dendrites wither through pruning. Basically, if you don't use it, you lose it. You hear that like with muscle and everything else. The same is the same. It's 100% true with the brain. The more you use a certain part of the brain, the more those pathways, they'll get stronger and stronger and stronger. They'll actually continue to as you use it more and more, it'll begin to create more and more connections between those neurons that communicate with each other regularly. So the pruning process then is basically like the parts of the brain that aren't being used actively, consistently, will wither to basically be replaced by other areas of the brain that are actually being used. Our brain does not like to waste energy. Our body doesn't like to waste energy, right? So I used to be in martial arts. I used to do judo and jujitsu and Krav Maga and all these other things. Lots of impact stuff, right? During that time, my knuckles got big and gnarly, but that was actually because they were getting hit all the time. I had calcium buildup in my bones. I gained weight, even though my body mass, like my look, didn't change. I got denser because of all the impacts, and that's your body's using it, so therefore it gets tougher. When I stopped, I lost weight because basically my bones and everything else got a little bit lighter because I'm not getting thrown on the ground all the time. Our brain does the same thing. Okay. Essentially, if you're using it actively, that area of the brain will become more active and it'll get faster and more efficient. If you're not using it, it withers away and fades. Part of the reason why it's actually important to keep being a learner throughout your life is because you're essentially keeping the brain active and strengthening the pathways that the brain has produced and began to produce in this early stage. Okay. Let's see. To allow space between neurons in the brain. So basically, the pruning process, we're cutting pathways, right? You got a giant bramble. We need paths to get through this bramble, and so that's essentially what the brain begins to do. It allows more synapses, those connections between the different neurons, and thus more complex thinking or sculpting. So experience expectant are going to be different. There are certain things in the brain basically that need experiences in order for them to engage. So that basically it'll be helpful with them. Okay, and then experience dependent are those areas where it's essentially if it doesn't happen, it won't. That part of the brain won't work. Okay. So experience expectant, the official definition with a book. Brain functions that require certain basic common experiences which an infant can be expected to have in order to develop normally. If they don't have them, they won't develop as they should, basically. Experience dependent are brain functions that depend on particular variable experiences and therefore may or may not develop in a particular infant. So you take an individual infant, right? Let's see, I'm trying to think of a good example one. A rough example, and we'll actually look at this more in I believe in the next module or next chapter. But they found experiments with people who are very highly neglected as children, like in the first year of life. They essentially never develop the parts of the brain that allow them to trust other people, and so it becomes very difficult for them in their adulthood to function in groups and to actually have any kind of a sense of trust and have connections with people. And so at its most extreme, where they're like severely neglected in their first year of life, it can lead to kind of psychotic issues and stuff. Psychopaths and things like that oftentimes they found have been neglected in their first year of life. So that's going to be what's there. Okay, we need that. We need to be hugged. We need to be fed. We need to have diapers changed or taken care of, cleaned up, all that kind of stuff. And if we don't get enough of that, then we can have issues. Okay. Next slide. Brain basics. A neuron, one of billions of nerve cells in the central nervous system. We have approximately, give or take, we have over, on average, 20 billion neurons in an adult body. Okay, so the neurons are in the brain, but they're also throughout the body in your nervous system and your spinal cord and all those things. There's actually also a whole bunch of them in your gut, but literally billions and billions of them. Axons are the fibers that extend from a neuron and transmits electrochemical impulses from that neuron to the dendrites of other neurons. And we have trillions, literally trillions of axons. Okay, by the time we reach adulthood. And this is where that process begins. The neuron is the actual cell. The axon is the part that reaches out to connect them. The cortex is the outer layer of the brain where most thinking, feeling, and sensing occurs. So we have, in the center of the brain, we have kind of the older parts of the brain that essentially keep our bodies going, right? Keeps your breathing happening, keeps your heart pumping. It's going to be regulating emotions to some extent, like if you're aroused, stress, and those kinds of things, or if you're calm and stable. Those are the older parts of the brain. The cortex is going to be this outer portion of the brain, and this is really basically what makes us human. It takes up about 80% of the overall mass of the brain is our cortex. That's where our thinking, our feeling, our sensing is all processed and gives us our conscious experience of the world. The prefrontal cortex, right here behind basically right behind your forehead, is the area of the cortex at the very front of the brain that specializes in anticipation, planning, and impulse control. And this is the last part of the brain to fully develop. It doesn't fully develop until you're around 25. This is part of the reason why we can experience. So think if assuming you're out of adolescence, okay, let's say you're in your 20s now or older. You might have noticed that you made kind of crazier decisions when you were in adolescence compared to now that you're out of it. That's partially because of the fact that your prefrontal cortex hadn't fully developed yet. So if you're 25, your brain is fully developed. If you're under 25, it's not there yet. It's still growing and developing. But it's the part of the brain that basically goes, I don't know if that's a good idea, right? This is why when I was in adolescence, I jumped a three-wheeler over 80 feet. I was about 18 to 20 feet in the air. Probably could have died. In fact, I very easily could have died, but I didn't, right? So therefore, I kept going. That's why adolescents typically do things like that. They'll do something that seemed like a good idea at the time. Looking back, you're like, boy, that was dumb. I started avalanches when I was backcountry skiing and stuff. The fact that I'm still alive is really amazing. But around 25, something clicks and you're like, oh, that's not such a good idea. Okay, that is the prefrontal cortex that does all of that. It's also going to be the part of the brain that goes, let's hold off on that, right? You're not so driven by your whims, basically, that when that is in control. Okay, 9, brain development part 3. The dendrites, a fiber that extends from a neuron and receives electrochemical impulses transmitted from other neurons via their axons. So this is the ear of the neuron, essentially. And it's going to be the part that's receiving the chemical connections that essentially causes the given neuron to either back off on its energy buildup or fire off into the next set of neurons and make that chain reaction continue. Synapses are the intersection between the axon of one neuron and the dendrites of other neurons. This is the tiny little gaps, okay? This is where the communication happens. Our neurons communicate back and forth with neurotransmitters, which are basically just chemicals that cause an electrical buildup in a given neuron, okay? That tiny gap, the receiving side has little, essentially like keyholes, and the sender has little keys, and they send out those chemical keys that fill in those keyholes, which will then stimulate the receive or block the receiving neuron. So the neurotransmitters are going to be the brain chemicals that carry information from the axon of a sending neuron to the dendrites of the receiving neuron. Okay. And this is going to be when you hear people talking about, what are some different things that would be like when you get like a runner's high and you have all of the increase in going blank on neurotransmitters. Anyway, there's a lot of different chemicals here. Opiates and things like that actually are going to be affecting the natural opiates that your brain produces. An opiate is essentially just a neurotransmitter. When you take something that's artificial, or at least not, you take some substance that has opiates to it, essentially they will be mimicking the natural ones that our body produces, which then causes issues. So, okay. Let's see. Boom, boom, boom. Slide 10. Connecting. The color staining on this photo. So this is a photo you can also find in the book, just in case you're not following along with the D2L or on the PowerPoint. If you look on page 88, inside the brain basics, you will see a picture that is on this one also. The color staining on this photo makes it obvious that the two cell bodies of neurons stained chartreuse grow axons and dendrites to each other's neurons. So that's where you can see the connecting pieces that are kind of a reddish color there. This tango is repeated thousands of times in every human brain. Throughout life, those fragile dendrites will grow or disappear as the person continues thinking. The more you use an area, again, the more those connections will develop. So you'll get more and more connections between the neurons. So essentially you go from an overgrown, hedge to a potentially a superhighway where information is able to travel crazy fast because there are so many connections in that area. The more you use it, the stronger and faster it becomes. Okay. The infant brain actually contains billions of new dendrites, and they're producing more and more and more and more of them every single day. And basically every thought, every experience, every sensation, all of these things cause the neurons to fire. Basically every experience you have, whether it's you thinking, you talking, you seeing or touching or smelling or whatever, all of the things that you experience in life are basically the reason you're experiencing them is because your neurons are firing back and forth and improving those pathways. Okay. All right. Slide 11. On this, we have an image that you can also find on page 89. This young boy enjoys the EEG of his brain activity. So this is a little thing. It's basically a bunch of little suction cups. They're not really suction cups, but essentially that's basically what it is. It goes on. It covers the scalp and allows them to see the electrical, how your electricity is essentially traveling through the brain. Such research has found that babies respond to language long before they speak. So we used to think that basically there was a certain point where our brain turned on. Babies are already responding to language, specifically the language that their parents speak regularly and while they were in the womb. Their brain is activating to it essentially, and it reacts different than other sounds in their environment. Experiences of all sorts connect to neurons and grow dendrites. And again, this is actually already happening in the womb. We have some basic memories where they found that if a mother sings while she's pregnant, when she gives birth, if she sings those same songs, the baby actually reacts to those songs basically right out of the womb. So there's already memories in place at birth. There's also, like if you read certain books, if the mother is stressed by somebody, let's say somebody becomes aggressive towards them and they like yell at them or something, when the baby hears the voice of the person that the mother became stressed by, the baby shows signs of stress. They've actually done blood work and stuff to see and how the brain fires. So the memories are in place early on. Okay, they're very basic memories, but they are still memories. Okay. Let's see. Slide 12. Infants need protection. This should be like a no-brainer, but they do. Okay. This is one I hate even talking about this, but shaken baby syndrome is a life-threatening injury that occurs when an infant is forcefully shaken back and forth. Don't shake babies. Don't hit babies. Don't throw things at babies. Babies just need protecting. They need comfort. Okay. If you shake a baby, their neck muscles are not strong enough to hold their head, right? If you've ever held a baby, you know that their neck muscles aren't strong enough to hold their head. The whipping basically of the head ruptures blood vessels in the brain and breaks neural connections, potentially killing the baby. At like the best case scenario you're going to have is some severe brain damage, and then death is a likely outcome of that also. Don't shake babies. Don't shake anybody, but don't shake babies especially. Okay. If a baby is crying, and this is usually what happens here, and before I move on, usually what happens here for the parents or the adults that do shake a baby is the baby is like colicky or something, and they just keep crying. When a baby cries, it actually triggers a stress response in adults, which is natural. It makes us want to actually get up and do something to help that baby stop crying. If the baby won't stop crying and the person is already struggling with issues, maybe they're on substances, maybe they're already just kind of unstable mentally or in like a depressive state or things like that, it can become overbearing or overwhelming basically for the adult, and the adult just wants to make the crying stop. And if you're not thinking correctly, if you're already under stress and things like that, it can result in shaking the baby. It happens much more often than I wish it ever did. It should never happen, but it happens pretty regularly. So don't do this though. Okay. Um, all right. Random fact number 2, before we move into slide 13. Random fact number 2, Princess Peach in Mario didn't move until 1988. Basically, the programmers felt like it was too complicated to make a movable movable character that you weren't actually playing before 1988. So Princess Peach didn't start moving until 1988. There you go, random fact. Okay, slide 13. Moving and perceiving, the senses. So the senses are going to be developed at different stages throughout after birth. Okay, our senses actually begin to develop in the womb, right? Like the first few weeks of life, we've already got our eyes and everything in place. They're just developing. They're usable to some extent at birth. Typically, our senses will develop before our intellectual and motor skills will develop, right? Our ability to hear, see, taste, smell, all those kind of touch will become more acute before we actually are able to think about what we're seeing or tasting and all that kind of stuff. Sensation is a response of a sensory system, so eyes, ears, skin, tongue, nose, when it detects a stimulus, right? If I touch something, whoop, I have a sensation that basically the nerves in my finger or hand, in this case, also, send a signal back through my nervous system into my spinal cord, into my brain, and my brain takes that information, interprets it, and says, you are touching something. Okay, kind of rough because you got calluses. Things like that, smooth down here on my desk. All of that kind of stuff is going to be that's a sensation. Okay, a perception is the mental processing of the sensory information when the brain interprets a sensation. So the signal being sent that I am touching something, right? Something is touching me. This thing's kind of pokey. The nerve sensations go up into my brain, and that's the sensation. The perception is when my brain says this is kind of pokey, or it's blue, or it's kind of smooth on the sides. Okay, all of those kinds of things. This is a pin. That's perception. That's my eyes taking in the color, my skin taking in the things. I could lick it if I wanted to. It's kind of gross, but yeah, all those things. Well, those are all going to be the sensation is the raw data going to the brain. Perception is what it does with that raw data. Slide 14, moving and perceiving the senses, part 2. Perception follows sensation, right? We cannot perceive something until we've already sensed it. And until we can figure out what we are sensing, we have no perception. Infants have senses. They can sense a lot of things. They have sensation. Even in the womb, but they have very little, if any, perception initially. Okay, so infants' brains are especially attuned to their own repeated social experiences, and perception occurs. They get a tummy ache, it's uncomfortable. They don't read it as, oh, my tummy hurts. They read it as just uncomfortable, discomfort, get rid of the discomfort, and they cry. If their needs are met when they cry, they start to perceive that when they have this discomfort, they can make this sound, and this sound will cause comfort to come. Okay, so infant brain and auditory capacity to hear sounds in the usual speech range. Our ears are basically programmed to hear the lowest to the maximum highest notes of the human voice. We are programmed to hear speech at birth. Okay, so the parts of the cortex dedicated to the sense develop rapidly. Hearing is actually our most well-developed sense at birth. Okay, so slide 15, which we look at hearing. Moving and perceiving hearing, you can see a picture that is showing here. It's showing where the brain is read on page 90. Okay, so just in case again. Sense of hearing develops during the last trimester of pregnancy. So you are, again, that last trimester, you are actually able to hear what's going on inside the womb, right? So you can hear your mother's heartbeat and her breathing and all those things, but you can also hear her voice and the voice of people outside of so that's why you can respond to music and books or stories or things like that regularly, or even the tone of someone's voice. It's the most advanced of the newborn senses. It is almost fully developed at birth, almost. Okay, it just takes a little bit longer for it to fully develop. And speech perception by 4 months after birth. So we are able to identify specific words and respond to them to some extent, a very limited extent. But we can tell when someone's actually talking by 4 months. Pretty much every child should be able to at that point. The right ear is going to be processed by the left side of the brain, and the left ear is processed by the right side of the brain. So that it crisscrosses basically in there in the processing. The left side of the brain is also going to be where the language portions of our thinking and our perception are located. So this is where our brain basically can break down and then produce eventually language. So you hear someone talking to you, and the fact that you can understand what I'm saying in this lecture is because of the left side of the brain. Okay. So it is possible, if those parts of the brain get damaged where the processing occurs in the pink and the yellow there, it is possible to be able to hear someone speaking to you, but your brain is unable to basically decode it. So you can hear it, but you can't perceive it as language. You can perceive it as sound, but that's it. Okay. It's also possible that you can understand language, but you can't speak it because the pink part of the brain, where you're basically where the words are formed, aren't there. You could also potentially speak it, but not be able to understand it when you hear it, if the yellow part's damaged. So weird stuff. Okay. Let's see. 16. Moving and perceiving, seeing. Vision is the least mature sense at birth. In fact, it's terrible. Your range of focus, binocular vision has not formed yet, so your eyes haven't connected with each other, which is why if a baby is staring at you, sometimes you'll notice like an eye is like, like you're like one eye kind of goes off on its own and does its own thing. That is because they haven't got in sync with each other yet. That generally they'll sync up somewhere between 2 and 4 months generally, but we can usually see somewhere between 4 and 30 inches. Okay. Why might that be important? I'm going to give you just a second to think about that. Why might it be important that 4 to 30 inches is the range of our sight? Why would we need that much sight even at birth? When you think about that for a second, we'll come back to it. Experience and maturation of visual cortex improves shape recognition, visual scanning, and details. So basically, the eyes begin to develop pretty significantly after birth. Like I said, binocular vision occurs somewhere between 2 and 4 months. Depth perception is usually present by 3 months. So once the eyes sync up with each other, we are now able to perceive that some things are further and some things are closer. Closer, further, right? And this is basically because the eyes are now able to judge, compared to each other, what angle they're at. And so if they're straightforward like this with each other, we know it's got to be far away. When things come up close, we basically go cross-eyed to see it. The fact that the eyes come in toward each other, our brain is then able to perceive the angle of that and recognize approximately how close it is. Now, back to the 4 to 30 inches. When I'm holding a baby, right here, 4 to 30 inches essentially is close enough that they can find the breast to eat and see the face of the person that's holding them. Okay. And so from birth, we begin to interpret the expression on faces and recognize faces, and we are learning through that process. This is why it's important to be able to experience that range specifically, is that we can see, essentially arm length in is where our ability to see comes from. Okay. Slide 17, moving and perceiving, tasting and smelling. Sense of smell and taste function at birth and rapidly adapt to the social world. They are there. Remember, they have the sensation, no perception yet. They have no experiences to be able to tell what the heck it is. So they could smell something, and they're like, that's an interesting smell, but they don't have like an interpretation of, oh, that's a nasty spinach beet baby food thing, or my diaper stinks, or all those kinds of things. That just isn't there yet. Dad must have tooted, all those. So foods and culture may aid survival. The child actually will learn pretty rapidly to associate the foods of their culture with good smells and tastes, which is why if you ever have traveled around the world at all, you might experience some foods that are unusual, to say the least, if you're American. Okay, all of a sudden you're eating like scorpions that are bathed in some kind of a chili sauce or something, right? Weird stuff. Crickets. I went to a friend's grandmother's birthday party. She was turning 93, I think, if I remember right. Anyway, she was old Mexican, and so they had gotten all of these things that were some of her favorite foods, and I was this big bowl of these crunchy little things that looked delicious, and I ate some of them, and they were delicious. And my friend's like, "Oh, I was surprised you ate those." I was like, "Why?" And he's like, "Those are crickets." I was like, "Whoa!" But anyway, very good, very tasty, very unusual for me to do that. I also learned that I do not like prickly pear salad. That was a weird thing, but or cactus salad. But the texture, the flavor was fine. The texture was rough. But those kinds of things are going to be what we learn in this stage, right? What tastes are good. Spicy foods are generally like, if you're from a family that eats spicy food, you're going to be more likely to like spicy foods yourself. You associate it with good. If you eat a lot of sour foods in your family, that's going to be a good flavor eventually. Sour and bitter initially are generally signals of potential poison or unripeness, and so therefore we don't necessarily like them, but we can train ourselves to. So adaptation occurs for both of these senses, the sense of smell and the sense of taste. Basically, we with experience, we learn to like or dislike certain things. Like this baby here, we have a picture. I think there's a picture of her in here also. Yes, on page 92, you see the same picture. This little girl licking a lime for the first time. You have that curious look on her face, the sudden realization of the mistake, and then like the blah, right, the gross, disgusted expression. This is a universal expression. If we taste something we don't like, the eyes squint, the nose squints or like kind of scrunches up, and the tongue pushes forward, blah, trying to push whatever it is out of your mouth. Get rid of that thing because it is possibly poison, so get rid of it. Okay. Protect the nose and protect the eyes from it just in case it's going to like explode in your face too. This will be the look even like if you smell something bad, you kind of, the whole face just rejects it. Okay, that's a natural thing. There's a good chance that's going to be the screenshot. Anyway, okay. Slide 18. Moving and perceiving touch and pain. So touch is a sense of touch is acute in infants, right? They have there's actually parts of the brain that can kind of tone your touch down. Okay. That part of the brain isn't really developed very well yet for babies. So something that we might experience as slightly uncomfortable, they could actually experience as very deep pain level-wise. Okay, that's also true within the womb. Their ability for the brain to turn off the pain receiving is not there, basically. Their ability to perceive it as pain is something debatable, but yeah, it's still, the sensation is going to be very strong and very intense for them. Although all newborns respond to being securely held, soon they prefer specific touches, right? All babies like to be, that's why we swaddle them and they're all like, blah, tied up. They like that. That tight feeling is what they basically came from, and it's comforting to most babies. But some babies are going to like specific ways to be held and specific positions and all those kinds of things, right? My one son, as soon as I tried to swaddle his little arms, he would literally just shoot his arms out because he didn't want his arms swaddled. But he liked his legs tight and he liked his body tight, and he liked to be held up close to me on his little tummy. So those are, that's kind of thing. My other son was totally fine, and my daughter was totally fine just being like totally squished in a little blanket. Although he did like his legs loose eventually. So some touches may be experience expectant for normal growth, right? We need to be held. We need to be swaddled to some extent. We need that person contact consistently. If we don't have those things, we have issues potentially later on in our development. Pain and temperature. So pain and temperature are often connected to touch, right? That's part of the sense of touch. Some people assume that even the fetus can feel pain, which is true. However, again, the perception is where the question comes in. Others say that the sense of pain does not mature until months or years later. You can experience pain, but are you really experiencing it as pain is basically the question. Okay. Also, real quick, the ability to be comforted by touch is actually one of the things that they look for in infants. If a baby shows distress at touch, that can actually be a red flag of different issues, such as they might be on the autistic spectrum or things like that, where they're basically the sense of touch is overloading, and so therefore, instead of being comforting, it can be stressful for them, and that's something that kind of a red flag. If they don't get comforted by physical touch, that can be a red flag that there might be something not going quite right in development. 19, moving and perceiving gross motor skills. So every basic motor skill develops over the first 2 years of life, from gross to the fine motor skills. You can see a detailed list of this as far as ages and everything on page 94 for the gross and the average months when they should be there. So course of development, cephalocaudal or head down, and proximal center out direction. We gain control of our head to some extent before everything else, and our mouth specifically we do gain control of, and then it basically goes from the center out. The last thing we really get control of is our legs and our feet. Our arms and hands come first because they're closer to the core. Okay. Interestingly, growth occurs the opposite direction. Your hands and feet will grow first, and then it works its way in and up. Okay. This is why you get that like awkward puppy stage where your hands and feet get huge, and like the rest of you eventually catches up. But then you also have that like gangly pony stage where your legs are super long and your arms are super long and your body's still small. Okay. So the sequence of emerging skills: sitting unsupported, which on average occurs around 6 months. Standing, holding on, crawling or creeping, and you can see all these again on page 94. Standing, not holding on, walking well, walking backward, running, and then jumping up. Most kids will not be able to jump up, like with both feet off the ground, until around 26 months old. Okay. That's going to be one of the last signs that in like early toddlerhood or middle of toddlerhood that they're developing well in that area. So again, you can see that on page 94 of the book. Fine motor skills, so slide 20. Physical abilities involving small body movements, right? The fact that I can pick up this pin and even wiggle it if I want to, that's a fine motor skill. If you can sew with a needle, that's a very fine motor skill. It's all that detailed work, like being able to spin a pin or do magic tricks or whatever. So especially the hands, fingers, such as drawing and picking up a coin. Shaped by culture and opportunity. Basically, the way this will develop will actually differ from culture to some extent, and the specific things that are important to that culture. You can see a list of these on page 95, as far as the specific ages when they might occur. But grasping a rattle generally is going to occur 3 months old, approximately. Where you put something in their hand and they'll intentionally hold it and actually kind of pay attention to it and do things with it intentionally. Rattles are actually a universal toy. Basically, every culture on the planet has some form of a rattle. And so there's actually an argument that if a baby doesn't have something to grab onto regularly, it can affect their development later on. So giving them a toy that they can kind of hold and manipulate that's appropriate to their age is an important part of development. Reaching to hold an object, where they actually they see their toy and they reach out to try to grab it. Thumb and finger grasping, the ability to grab something. Stacking 2 blocks, and then imitating vertical lines where they can actually draw a line with like a pencil or a crayon or something. Stacking blocks generally occurs around 21 months, and then being able to actually draw a line doesn't usually happen until around 3, where they can intentionally draw a straight line and get it to do what they want it to do. Okay. Yes, vertical would be this way, not horizontal. Anyway, okay. Okay. Next slide. And again, there's more details. You can go really in depth in here in the book. So just make sure you kind of read through the book to get the ages specific and things like that. Slide 21, infant cognition, Piaget, part 1. So sensory motor intelligence. So Piaget, remember, the 3 big developmental people in the older days of psychology are going to be Freud, which is questionable, Erikson, which built off of Freud but really did make it a little better, and then Piaget. Erikson and Piaget being the 2 biggest ones. Sensory motor intelligence is Piaget's term for the way infants think by using their senses and motor skills during the first period of cognitive development. Essentially, it's a simpler. The thinking, and again, this is his observations from watching babies and how they kind of interacted with the world. Essentially, he felt like it was kind of a compiling of data through the senses in order for them to then think about it later on in life when they develop the tools to do so, such as language. This is the earliest form of thinking, of the brain working out of all of them. Okay, you can find actually a table of his stages of throughout this on page 97. Okay, slide 22 and this is going to be the detailed stuff. Stage 1 is the reflexes. It takes no thought, right? And this is what they're checking when you're at birth. You put your finger in their hand, and they grab on tight. That's a reflex. The ability to suck, right? You put something to their lips, and they just start sucking on it. If you've ever held a brand new baby, like they'll suck onto your nose, your chin, or your cheeks, or whatever. Like anything they get their mouth on, they start sucking. That's a reflex. They don't have to think about it. There is zero thought actually that occurs with that. Staring. Okay, that takes no thought. That's actually a reflex. Listening. Those are all reflexes. And that's going to be the first stage. The first birth to about 1 month old approximately is going to be just that. Okay. Stage 2, first acquired adaptation. So stage of first habits. So first acquired, examples, sucking a pacifier differently from a nipple, attempting to hold a bottle to suck it, right? It's the beginnings, like they recognize that there are differences and they adapt to that, which can then lead to eventual habits. That occurs between 1 and 4 months. Stage 3 attempts to produce exciting experiences, making sights last. Clapping hands when mother says patty cake, okay, is an example of this. They begin to interact with it, okay, and they're interacting with their environment more. This can also be where the baby begins to like actually do things. Like let's say they do something and they make somebody laugh. Most babies like the sound of laughter, and so they'll keep doing the same things to try to keep engaging that laughter. Okay. Stage 4. So sorry, next slide, 23. Stage 4. New adaptation and anticipation means to the end, more attuned to goals of others, increased social understanding, and they begin to experience object permanence, according to Piaget. Object permanence, before this, when you play like peekaboo and I go, peekaboo, where's dad? Before this, apparently, as far as the baby's concerned, especially if I went like this with a hat, dad just disappeared. He is no longer anywhere on the planet. And I go, peekaboo, here I am. And suddenly you're like, bah, there they are. Okay, they're back. To this stage, they recognize the fact that just because they can't see me, right, just because I've covered the screen, doesn't mean that I'm gone. Although I'm not really here, I'm just on your computer. But anyway, so yeah, that's going to be object permanence. This is why peekaboo becomes a fun game in this stage. This is between 8 and 12 months. And this is also when you might begin to see stranger awareness occur. Okay. And so they're aware that suddenly, mom or dad leaves. They're not necessarily just gone, but at the same time, they're actually aware of the fact that they've left, and that becomes an issue. Stage 5, new means through active experimentation. They're little scientists. Trial and error. This can be a stressful stage for parents. So 12 to 18 months. This is where you get the kid that like they take the toilet paper and stick it in the toilet and flush it, and then, whoa, that was a neat reaction. The toilet paper just flew into that toilet. We'll just keep on doing this, and then you get the plumber's bill and stuff later on. Things like that. Okay. Dumping a bag of flour all over the place. I had my oldest son when he was this age. Dumped a bag of powdered sugar everywhere. I did not realize how big of a mess powdered sugar can make. But you're like, I covered everything. It was amazing. But yeah, stage 5 or stage 4. Sorry, stage 5, right? They're experimenting with it. They want to see if they want to see what makes things do what. This is also where they can begin to actually do things to intentionally get a reaction from the parents or adults in their life. They begin to learn how to push your buttons, basically, and they're doing it not to make you annoyed, but to get a reaction. Okay. Stage 6, mental combination use, intellectual experimentation via imagination, and deferred imitation. They're beginning to think. Okay, at this stage. They want to stuff their teddy bear down the toilet, right? But the little voice in the back of their head says, that might not be a good idea. Last time I did something like that, I got in trouble. Okay. They want to chuck a toy at that other kid in the room. Oh, but last time I got a timeout when I did that. I probably shouldn't do that. Okay, those kinds of thinking begin to show themselves at this point. And you can see them. They'll pause for a second and think about it. They might still do it, but that pause is key there. Okay. So yeah, doesn't necessarily take the trial and error that it took before, now they're able to kind of process, like, or they'll look at something and like, this is similar to that other thing, and I might get the same kind of reaction. Okay. Slide 24, Piaget evaluated. Basically, how accurate was Piaget, right? Careful observation of child cognition at each stage inspired future research. He really is that. The biggest thing he did was he really inspired researchers today in kind of understanding the stages of what's going on inside the baby's brain. He had an underestimation of age at which various accomplishments occurred, which, I mean, honestly, if you're just observing a baby, it's really hard to tell. Like a 3-month-old baby, you cannot tell what the heck is going on in their mind, right? Not much is happening externally, therefore we can't get much of a reading internally. And that's true for most of infancy. What they found today with all the tools they have to be able to read what's going on actually in the brain is that what he thought was happening at a certain age sometimes is actually happening much earlier in the child's development, even though there's no external evidence of it. Sensory and motor ability emphasis limited understanding of early child cognition. He was focused on what he could observe in their body because that's all he had to observe. He didn't have the tools to observe what was going on inside the brain. That's only recently since we've developed the tools to do so. Okay. And that's essentially, those are the only criticisms that Piaget has. He was a little off on his ages because he didn't have what was actually happening in the brain. But generally speaking, all of his stages are accurate, just slightly off age-wise. Okay. Pretty exceptional. Very impressive person. Slide 25, infant cognition, part 1. Information processing theory. So model on computer functioning. Involves step-by-step description of the mechanisms of thought. So adds insight and understanding of cognition at every age. Has overturned some of Piaget's conclusions, including the concept of object permanence. They found that basically babies have a sense of object permanence earlier. They just don't react to it yet. Okay. But yeah, essentially they're looking at data in, data out kind of a thing. Somewhat like behaviorism, but more focused on what's actually happening within the brain itself rather than just the physical reactions to things. All right, 26, infant cognition, part 2, early memory. According to classic developmental theory, infants store no memories in the first year, infantile amnesia. So that was what people used to think, basically. Developmentalists now agree that very young infants can remember memory, but memory improves monthly. Like I said, they found that even within the womb, we have some basic memory, right? We react to certain things. So memory is present very early on. It just is. It's a difficult way to access it, which is why we experience infantile amnesia. Essentially, until we have language, we have a very difficult time of storing the thoughts and feelings and things and experiences in a way that's easily accessible. Roe v. Collier's mobile kicking research and others basically have proven this to be the case. The brain is an active organ even in infancy, and infants remember not only specific events and objects, but also patterns and general goals. This experiment was basically, they took babies, little tiny babies, and they tied a little string around their ankle that they tied to a mobile, like those things that spin around them and play music. And every time the baby would kick, the string getting pulled would cause the mobile to turn and play its music. What they did is they took a bunch of babies and had them do this, and they took them away. They brought them back in 2 weeks later, and they brought a bunch of babies who hadn't had the same experience, that were the same age though, and they tied them up to these mobiles again. And they found that the babies who had the experience 2 weeks earlier were much quicker in starting to kick to get the mobile to spin, whereas the other babies basically stumbled on it by accident. So there is some memory there. That was an experiment to prove memory. Okay, slide 27. Language, the universal sequence, part 1. Language and responding, so child direct speech or motherese. This is baby talk, okay? And this is actually an important part of development. So this is when you're like, oh, look at you. You're just such a cute little kid. Okay, you do this with pets too, right? Humans tend to do this with small children and pets. But you notice that when I do that, my pitch goes up, right? I'm talking to you and I'm talking in my normal grown-up voice. I talk to a baby and my voice is here. Oh, you're such a cute little guy. Okay. And the voice kind of gets scrunchy. Okay. And I might repeat myself over and over and over again. That is going to be that motherese. We're going to look at that more in depth here in a second. Babbling is connected to gestures. We're going to look at that more in depth too. This is kind of a quick rundown of what we're going to be looking at here. First, words and hollow phrases, verbs and nouns, and the naming explosion that occurs, and then putting words together, grammar, and all that. So, slide forward. Slide 28. Child-directed speech, that high-pitched, simplified, and repetitive way adults speak to infants. Baby talk, motherese, officially is called child-directed speech. But this is that engagement that we have. Our voice goes up, and we say the same thing over and over again. Look at you. Oh, you're so cute. Oh, you're just the cutest little thing. Okay, same thing, might be slightly different, but repeatedly saying the same thing. Oh, you sad? Don't be sad. You don't have to be sad. And we usually are reflecting the emotion that they're giving us at the same time. If they're happy, we're happy. If they're sad, we're sad. Right? We kind of exaggerate it. That's important, though, because the baby begins to associate what they're seeing in our emotions with the emotion that they're feeling. Babbling is the extended repetition of certain syllables, such as ba, 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 or that begin when babies are between 6 and 9 months old. Gradual imitation of accents, cadence, consonants, and gestures in the environment also get picked up in this period. Okay. The sounds that they hear spoken around them constantly are going to be the sounds that they produce. For example, this is also why, actually, to some extent, the English language is kind of flattening as far as accents go, because they're exposed to so much just kind of like this flat English that they see on TV, that it's killing accents worldwide. Okay. To some extent. It's also creating accents where there didn't used to be some. They've actually done experiments. They found that kids that watch Peppa Pig, for example, especially if they watch a lot of it, they're picking up British accents in a lot of ways, and expressions. Shows that they're probably watching way too much TV for their age. But so they'll say things like, Mother, are we going on a holiday, instead of are we going on vacation, things like that, when they get like 3, 4, or 5 years old. Okay. Even though they're from America, where that's not normally the phrase. Slide 29, language, the universal sequence, part 3, first words. At about 1 year, babies speak a few words. Okay, right? You might hear like da da or mama, things like that, right? Those real basic, and it's usually even words that other people, if they're not part of the family, they won't have a clue what the baby's asking for or talking about. But the parents do, because they're around them all the time. Spoken vocabulary increases gradually, about 1 or 2 new words a week. And you'll get a lot of hollow phrases. So single word used to express a complete meaningful thought, right? Da-da. And like as soon as, if you're the dad, you know what that word means, and you're like coming in to, you pick them up because their little hands are up and all that kind of stuff. Okay. You might even hear like baba, which means bottle, or a favorite stuffy, or maybe a diaper change, whatever like everyone else is like they're asking for, but the parents know what that is. Infants differ in use of various parts of speech depending on the language they are learning. So for example, English is a very noun-heavy language. We have about 70% of our words are nouns. We name things. Part of the reason why our language is so effective in science and things like that is because we have so many names for things, right? We like to have that. Other languages are going to be more verb-heavy. A lot of cultures that are more nature-based. I'm trying to think of an example. Let's see. So like Shawnee, the Shawnee language of the Native American, one of the Native American tribes. It's basically flip-flopped from English. It's about 70% verb-based. So they'll say things like, instead of saying a bay, like we're looking at a bay in the ocean, they'll say to be a bay. The water is a bay. Okay. They verb it. It actually changes the perception of the world around you. Depending on the language you learn and what language you use to think will change how you interact with the world around you. But the child basically begins to pick that up in this part of life. Okay. That's also true. There's actually a lot of tribes in Africa that they're very verb heavy. They verb things that would normally just be named in English, and it changes how they experience that thing. Weird stuff. We'll look at that more in depth too. 30. Language, the universal sequence part 4. Actually, I take that back. If you really want to dig into that, take Psych 101. We dig into that a little bit more in that one. How language, at least in my classes, we do. how language can shape our view of the world. Okay, slide 30. Language, the universal sequence, part 4. Verbs and nouns, the naming explosion. So once vocabulary reaches about 50 expressed words, it builds rapidly at about 50 to 100 words per month. 21-month-olds say twice as many words as 18-month-olds on average. And the ratio of nouns to verbs may vary from place to place. Again, depending on what language you're exposed to and the level of that, it will differ. So if you are a verb-heavy language, then you're going to learn more verbs than nouns to begin with. If you're a noun-heavy language like English, you're going to learn more nouns than verbs. Okay. Let's see. Let's throw out the next random fact. Forrest Fenn hid a treasure chest in the Rocky Mountains worth over $1 million, and it still has not been found to this day. You can actually, if you Google Forrest Fenn, you can find him on there. He was a I think he's an art curator, if I'm right. But he gathered up $1 million worth of stuff. He was very wealthy. Put it in a treasure chest and hid it somewhere in the Rockies. And then he gave a series of clues to find it. You can find those clues online. Just Google Forrest Fenn. Okay. Weird stuff. Funny guys. Okay. Kind of fun though. Slide 31. Language, the universal sequence, part 5. Putting words together. So grammar includes all the devices by which words communicate meaning. Sequences, prefixes, suffixes, intonation, volume, verb forms, pronouns, negations, prepositions, and articles. There's probably other ones in other languages, but these are all the core ones, right? We pick this all up basically by osmosis, right? No one officially sits down and says, this is the proper sequence that words should be put into, or here's a pronoun, or the various articles and things like that. They don't teach you that straight up. We pick it up through our experience of talking with people using the various languages. So proficiency in grammar correlates with sentence length. So yeah, I mean that's essentially going to be the keys there in that. Oh, real quick, on page 105, it actually don't have this in here, but on page 105, there is a little graph that shows kind of what to expect in communication. That's a really good tool there. An MLU is the mean utterance or mean length of utterance. And that's how many words can you string together, right? If you're Charles Dickens, you can string a whole lot of them in one sentence, right? But at this point, they go from one word sentences, where it's just literally one word that they're getting all of their point across, to 2 words, to 3, 4, 5 words. You know, the sentences get longer and longer, and more complex, and start utilizing more and more of all of these grammatical tools. Okay, 32. Theory 1, infants need to be taught. So we're going to be looking at a few different theories here. B.F. Skinner, 1957, noticed that spontaneous babbling is usually reinforced, right? Baby goes, ba, 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 or da-da. And immediately dad's like, yeah, great job, baby, you said da-da. You know, like, that's me, I'm da-da. Okay, that praise, the baby's like, whoa, that got a big reaction. That praise, that reinforcement, da-da-da-da-da-da from the dad, suddenly becomes like they'll be more likely to make that sound again. Okay. So parents are expert teachers, and other caregivers help them teach children to speak, right? The humans, for the most part, as adults, we are programmed to talk. We are programmed to communicate. And because of that, we are very good at basically connecting with children and infants and talking with them usually, right? Frequent repetition of words is instructive, especially when the words are linked to the pleasures of daily life. Well-taught infants become well-spoken children. The more you communicate with your infant, the better they'll be with language as they get older. There's a little picture here of a graph. You can find this on page 109. Okay, but it shows the difference between the infants of highly responsive top 10% mothers and the infants of less responsive or bottom 10% mothers. These are people who, like, as soon as they, the top 10% would be like the baby makes down and they're there interacting with them, right? Low end, Okay. Nowadays, that's a big issue, actually. But at 13 months, the babies that were of the mothers that had, basically at 13 months, they're almost the same. Didn't matter how responsive the mothers were. Language-wise, they're about the same. The difference was what happened rapidly right after that. For the highly responsive mothers, by about 15 months, the babies were hitting the 50-word mark, and the naming explosion that happens. Okay. For the unresponsive mothers, that 50-word mark they weren't hitting that mark until about 21 months, which at that point the naming explosion happens. So there is approximately a 6-month difference between the two extremes, which means basically that the kids with the most responsive mothers have an advantage in their language skills over those of the unresponsive mothers. Now, did that mean that the unresponsive mothers have ruined the lives of their children? No, right? They usually do fine, but it's easier basically for the kids that have those more responsive mothers. Okay. 33, theory 2, social interaction approach. Social interaction fosters infant language. Okay. Infants communicate because humans have evolved as social beings. This is another theory, right? So Skinner, remember, he's a behaviorist. He's saying, it's behaviorism. It's programming in that you get rewarded for these things, and so therefore they do it, and that's why they do it. They've been conditioned to speak. Social interaction. This social interaction approach basically says, not necessarily. Infants communicate because humans have evolved as social beings. We are created to talk, to communicate, to be social. So each culture has practices that further that social interaction, including talking, right? Talking is one of the most effective ways to communicate. And social impulses are not explicit teaching, lead infants to learn language. They learn language because it's pulled out of them essentially because they want to engage socially, right? Our very nature makes us want to engage in the group. Because of that, we learn language, not because we're taught to learn language, but because that internal drive. Okay. This should say theory 3 on the slide. Sorry, I just realized it says theory 2. Slide 34, theory 3, 2, okay. Infant self-teaching approach. Infants teach themselves. Language learning is innate. Basically, it's in our brain somewhere. Adults need not to teach it, nor is it a byproduct of social interaction. Essentially, the tools are all there. It's just in us. We learn the specific details of a given language through interaction with the adults. Okay, so Chomsky felt like this was the case. Language is too complex to be mastered through step-by-step conditioning. He felt like there's just too much that happens in such a short amount of time. It has to just essentially be the brain is pre-wired to do this. It just picks up the details from the specific culture that it lives in. So language acquisition device, or LAD. It's a term of the hypothesized mental structures that enable aspects of grammar, vocabulary, and intonation. And he felt like these are just kind of in place within everybody's brain. Okay. So slide 35, all true, right? All perspectives offer insight into language acquisition. Basically, is any one of these the answer? No. Okay. What we've been finding basically is that essentially they're all true to some extent. Okay. Conditioning is a factor in our learning of language, right? If you get positive responses, or if I say baba and then like you give me a bottle, I'm like, hey, if I want this bottle and I make this sound, I get this bottle, right? Makes me more likely to say it. I don't know why I sound like hey, give me a bottle, but the social anyway. Social interaction fosters infant language, right? Like our desire to connect with the social group is a part of it. And also our brain is in fact wired to do language. So all three of these things are true. It's just different parts of the big picture, essentially. So different elements of the language apparatus may have developed in different ways. Current thinking, children are not exclusively behaviorists, social learners, or innately driven, but all three. Evolutionary theorists posit that language is a crucial trait that makes humans unique, right? Pretty much every animal on the planet that lives in a big group has some kind of communication. We just happen to have one of the most complex, not just happen, we do have the most complex language system on the planet as humans, right? The fact that we even have multiple languages, and each of them if you ever try to learn more than one language, is unbelievably complicated. If you ever just try to learn your own language, right, it's unbelievably complicated. So that complexity has opened up all of the doors for us, basically, to do what we have done as a species. Okay. 36. Surviving and thriving. Better days ahead. United Nations estimates that more than 8 billion children were born between 1950 and 2015, and that almost 1 billion of them died before the age of 5. So 1 in 8 kids that were born died before reaching the age of 5. Now almost all newborns who survive the first month live to adulthood. Basically, the first 6 months of life are really the scariest. There's the highest chance of various things going wrong, and the child just going to sleep and not waking up. Once you made it past that 6-month mark, usually you're somewhat in the safe zone, other than like choking hazards and things like that. Infant survival and maternal education are the 2 main reasons the world's fertility rate in 2010 was half that of 1950. So the number of children being born has decreased, but the number of children surviving has increased, which is good. Okay, at least the surviving part, definitely. The being born part is questionable depending on the country you're looking at. But anyway. Slide 37, understanding sudden infant death syndrome, or SIDS. Until the mid-1990s, tens of thousands of SIDS deaths in North America and England. Most deaths were sleeping position related. So if you ever go back and read, I don't necessarily recommend doing this if you're actually looking for advice on parenting, but if you ever go back and read like parenting books from the 1980s and the like, a lot of those books recommended having your child sleep on their tummy. Okay, if you've had kids in the last 20 years, you know that's not good. Okay, tummy time is great. Put the kid on his tummy for a little bit, but they need to spend most of the time on their back as infants before 6 months old, because essentially when they're sleeping on their tummy, they run the risk of basically getting smothered by the bed, which is terrible. And so the baby goes to sleep and it doesn't wake up. So yeah, other risks: low birth weight. Babies who are born with a low birth weight are at a higher risk of SIDS occurring. Exposure to cigarette smoke, and actually exposure to pollutants in the air, not just cigarette smoke, any smoke at all, as well as other pollutants in the air. So if you live in an area where there's high pollution, say like inner city LA or something like that, there's actually a higher chance of SIDS occurring in those environments. Soft blankets or pillows, take all of those out of their crib. Just give them warmer jammies. Okay, those have increased chances, because basically, especially with a brand new infant, the blanket comes over their face and they can't get it out. Bed sharing. If the baby is sleeping in the bed with the parents, there is a chance of parents pull the blankets up when they're asleep, pulls it up over the face of the baby. The baby's lungs aren't strong enough and they suffocate and die. I couldn't even imagine. That would be horrible. Abnormalities in brainstem, heart, mitochondria, or microbiome. Basically, if there's a biological issue, baby was good enough to live yet, but not. It gave out on them in those first times there. This is a really hard one. It can be devastating for the parents, losing your baby early on like that. But it happens more often than we wish. Less often than it used to. Again, one of the big answers was just turn your baby on its back while it's sleeping, and it suddenly has a much lower chance of suffering from SIDS. Okay, slide 38, success in survival, immunization. So primes the body's immune system to resist a particular disease, contributes to reduced mortality and population growth. Successes are things like smallpox, polio, and measles. They've been big successes. These were all diseases that used to kill a lot of people. And they for the most part, have been eliminated from the world. They're still there. We just aren't susceptible to them anymore because of immunizations. Now, there is some debate over immunizations just because of the fact that they're we'll look at that here in a second. Anyway, babies getting shots, basically. Slide 39. Success and survival part 1. Immunizations are unsafe for embryos and rubella, newborns, people with compromised immune systems, and this is where herd immunity becomes a thing. So that herd immunity essentially is like a certain percentage of the population is immune to a given disease, and then the people who aren't immune to it are essentially protected from it because there's a high enough percentage of people that can't get it, that it's highly improbable that that individual would get it themselves. Problems, there can be reactions to the immunizations depending on what's in them, especially if there's allergies, things like that. Potential side effects. And then parental refusal myths. So this is where some of the debate comes in. So when I was a kid, for example, I think there was 8 immunizations that they gave babies. Nowadays, there's well over 30 immunizations they give babies, and they're starting to look at is this many immunizations a good thing in the short amount of time that they give it to them, primarily because it causes the immunizations themselves do cause inflammation within the body. So they're beginning to do research. There's been a rise basically in autoimmune diseases and things within the last 15, 20 years with younger people. And they're wondering if it might actually be because of the fact that we get so many immunizations so quickly. If this is actually causing basically that heightened level of inflammation in the body to have a negative effect upon the body's immune system and how it kind of reads itself. They're still in the research process of that. But good news is we don't have things like polio, right? That killed millions of people every year. It was awful. Even if you survived polio, you were paralyzed generally. And so yeah, that was a bad one. Same with like smallpox, the high death rate with smallpox. Measles actually killed millions of people every year. People don't think about that. German measles specifically killed a lot of kids died. A lot of adults died of measles every year. Okay, so kind of a double-edged sword there, but each to his own. Okay, slide 40. Oh, sorry. And so real quick, some of the myths around them. That immunizations cause autism. There has been no evidence that immunization caused autism. There was one doctor who claimed that they did. Turned out that he was actually paid a lot of money to make the claims, and nobody has been able to duplicate his research. And so essentially, but that was back in the late 90s, and that has stuck, that it causes autism. I have a couple of friends who are actually on the autistic spectrum, and they find it extremely offensive that they, that their way that their brain works, people think it's because of the immunizations. To them, they're just different, and that's not a bad thing. So it can be rough, but it's got its own things. It's actually the majority. They've actually done a study. They found the majority of engineers, like well over 50%. I think it's closer to 70% of engineers have actually been found to be on the spectrum. So there's something about the way the brain works that can actually be an advantage if you're a high functioning autist with autism. So slide 40, success and survival part 2, adequate nutrition, breastfeeding. For every infant disease, including SIDS, breastfeeding reduces the risk of malnutrition. Reduces the risk. Malnutrition increases it, stunting growth of body and brain. Breastfed babies are less likely to develop allergies, asthma, obesity, and heart disease. And as the infant gets older, the composition of breast milk adjusts to the baby's changing nutritional needs. So it's not just a one-size-fits-all. It basically, the nipple actually has sensors on it that pick up different chemical connections to the lips of the baby and will adapt the milk to the needs of the infant, which is why actually people who have twins, if one twin nurses from one breast and another twin nurses from the other breast, the milk makeup in both breasts can be different because it's specifically shaped itself essentially to the needs of the individual infant. It's amazing stuff. Now, does that mean that if you didn't breastfeed your children, that you've ruined their life? No, right? In some cases, mothers just can't produce enough milk. Other cases, there can be issues or health issues or things that can make it difficult or even impossible for the mother to breastfeed the child. And thankfully, we have amazing formula nowadays that allows for us to still meet the nutritional needs of infants. It's just generally breastfeeding is the better of the two. Okay. Yeah, and that's essentially what that comes down to. You can see a table on page 119, table 3.2. There's a list of the benefits of breastfeeding there. So, Slide 41, malnutrition, protein, calorie malnutrition, condition in which a person does not consume sufficient food of any kind that can result in several illnesses, severe weight loss, and even death. This is just where at any age, you're just not getting enough food, essentially. Okay. It can lead to stunting, which is a failure of children to grow to a normal height for their age due to severe and chronic malnutrition, right? If your body doesn't have the tools it needs to grow, it can't grow. The normal process is going to be like the kid will be awake more and they kind of get chubby, like they're eating nonstop, and then suddenly they're off their feed and they're sleeping all the time, and that's growing period. That's going to be the normal rhythm. But if you can't get enough excess to get that tummy, you won't grow as much, essentially. Wasting is a tendency for children to be severely underweight for their age as a result of malnutrition. Thankfully, wasting has decreased significantly over the years. Real quick, random fact, number 4, the world's largest grand piano was made by a 15-year-old kid in New Zealand. Okay, there you go. Grand piano, 15-year-old kid in New Zealand made it. Biggest one. Here we go. Slide 42. This is actually a graph showing the prevalence of stunting in the various world regions from 1990 to 2015. Blue is 1990. Basically, in this one, we want to see the numbers get smaller. Okay, which worldwide, every single area of the world, there is less stunting occurring today than there was in 1990, at least as of 2015. Okay, I haven't seen any evidence of this recently, but that's the last time I've had any of this. Areas that experience civil war, that there is like desertification and things like that. Like families are just having great big families, but they're poor. Those increase the chances of stunting because of food scarcity and things like that. So yeah, East and Central Africa, it's still relatively high compared to the rest of the world, as well as South Asia. South Asia also has a very large population, so again, that's the issues there. But it's decreasing still, right? So those issues are becoming less and less an issue. Remember, South Asia also includes India, which has over 1 billion people. So there's chances of that being relatively high there. Okay, that's everything. So thank you for watching this. Remember to do the quiz, the 4 different pieces there. As always, message me if you have any questions or send me a discussion chat or something, and I'll do my best to get to you right away. So yeah, until the next one, see you later. Have a wonderful day, week, whatever it happens to be that you're after you watch this. Good luck with everything, and I'll see you in the next video. Have a good one.